quality engineering and expect to turn in a permit application for a new plant probably November, December of this year.
Oh, wow, that's coming up quick.
It is. The process once you do that is then it goes to the Department of Environmental Conservation, it goes to EPA, there are mandatory comment periods, and if anybody has been watching the push and pull on Healy Clean Coal down in Healy, it's not a guarantee that a permit application gets approved without modifications or changes to your design, and so we really expect there'll be a year of that as well. And so in the upcoming legislative session, let me back up. Currently, we're spending about $3 million on the work that I've just described. In the upcoming legislative session, the Board of Regents likely will have a $22 million capital request that essentially will fund the complete design up through bid ready for the entire plant. And that'll be $22 million. It's about 10% of the cost of a facility is what is a rule of thumb for design. And so we'll have a FY14 request for design and then a FY15 request for capital funding to actually build the plant, with the hope that we're building it in 2015 and 16 before we have some catastrophic failure in our 50-year-old plant that is currently there. And so that's kind of both the thinking and the plan as we put together the biggest component, which is the big heat and power plant. Then we also pull in, well, what other things can complement that? And so we're talking with Golden Valley about participating with the wind at Eva Creek. We're looking at options for solar, particularly on West Ridge, to essentially provide the shoulders for that amount of power that you don't have to do supplemental firing for. And with a combination of solid fuel, which is coal and biomass, with some wind and some solar, and then we also currently have what are called EPCs, which are energy performance contractors on campus that go through your buildings, recommend retrofits, and do the retrofits financed with the savings. So to the extent we can make our buildings more efficient, that affects the size, the ultimate size of the plant that we have to build. And so really we're looking at all those components at the same time. It's just the biggest piece that gets the most attention, which is the new plant.
Right. Now, Bob, with this new plan, how do you see it benefiting UAF not only in the initial first steps, but also in a long-term perspective?
Well, part of what you do when you design a new plant is you have to do projections on demand into the future. And so you start by looking, well, what has demand growth been across the last 30 or 40 years? And then make some assumptions about what it's going to be. And then you size your plant so that you're not overbuilding, but that you have enough in 20 years or 25 years that you can still meet the load demands of campus. And so by appropriately sizing the plant, it'll do two things. One, there'll be growth capacity into the future, because the big money is in building the plant and putting in the boilers, and incremental capacity for steam or electricity is most cost effective to be done when you're building. So one, you want to size the plant right. And then the other thing that does is if you build it for a 30 or 40-year horizon, you've got excess capacity in year one. And so we would also then look at, can we provide low-cost electricity back into the grid that Golden Valley can buy and share around town? And then across time, as our demand grows, the amount that would go back into the grid would shrink, but there would be a benefit for the whole community rather than have 1/3 of the plant sit idle for the first 10 or 15 years. And so that really is how you approach the long-term question of what do you do when you're putting in a whole new plant.
Okay, I see. Well, and that kind of brings me to my next question that I want to ask you. We spoke a little bit earlier in the week about the new additions to UAF as far as buildings and structures. And UAF is a constantly growing campus from what we spoke about. How would you say with this new plan, because the main idea of it is to be cost-effective, energy efficient, would you say that the plan will be able to maintain those ideas through the growth of UAF in the future? I mean, as you add on, more square footage and more buildings and.
Yeah, the answer to that is yes, and some of that has to do with the sizing. You make sure that you're sized for, because right now as you drive around campus, you see the new life sciences building go up. Every time you add 100,000 square feet, you add a considerable heat and power load. And so the growth demands are part of that analysis of how big does your plant need to be. The other piece is, as part of the life sciences project, we ran a new utilidor that ran all the way from the current site of the combined heat and power plant to the West Ridge. And so that we could increase the size of the steam pipes that were running up there and have enough heat capacity into the future. So the new plant will go right adjacent to the existing plant. The current coal boilers will be decommissioned, and that will provide enough heat and power for campus out of the new plant, and then we plan to keep operational the coal/natural gas boilers that are there, so that if there's some failure of a sort, we can switch to the 1978 to 1980 era boilers, and that also gives you additional growth room if things do change, and there's growth beyond what we expected.
Okay, all right. And I would just like to bring this interview to a close with one last question.
Sure.
As far as this new energy plan with UAF, do you see it being complementary to the community of Fairbanks? Do you see it influencing at all or taking any influence from the energy plan within the community?
I would say it's complementary. If you look at a lot of the efforts and driven tries by whether it be the borough or Fairbanks Natural Gas or Golden Valley or Flint Hills, have been to lower energy costs, particularly for space heating for the community. Natural gas and liquefied natural gas appears to be the first step of that. The hope is that a pipeline of gas follows that. And there's a couple of ways that fits in. Right now we burn 1.2 million gallons of diesel a year at UAF as supplemental firing. If there was a gas supply, we would immediately switch to using gas rather than the high-cost diesel, and that would be immediate savings, and it also provides additional demand for making the current projects that are being discussed more viable. Down the road, if there was a large diameter pipeline, we would already be set up for gas. The solid fuel boilers could be converted, but then it's an economic decision and what and how can you do that. And so if you had a big diameter line that was similar to a GIA that had been talked about with net back pricing based on the distance from the North Slope to Fairbanks as the tariff rate, you would expect low-cost gas competitive with coal. And then we would look at switching over totally based on the economics of it. Mm-hmm. And so I would say the use of gas is one piece. The electricity back into the community based on a low-cost provision, and that will depend a lot on Golden Valley's need, Golden Valley's dependency on oil, and whether or not there's a new coal mine, or not coal mine, new gold mine up north that increases the demand that Golden Valley says, now we need more generation capacity. And then the final piece that we've talked to Aurora Energy about that's kind of a possibility down the road is, if you're familiar with town, Aurora 1 is the old MUS power plant on the Chena River. It is very similar to our existing boilers that are really aging out. And at some point, they are going to start having issues and questions of how do we keep running, what happens if we have a failure. And right now, if Aurora 1 has a failure, there are a large number of buildings right in the downtown core that are at risk, very similar to if we have a failure, our campus is at risk of freezing up. And there's a possibility of high pressure, high temperature line that would run the railroad corridor between UAF and Aurora 1 so that we could essentially provide backup for each other and eliminate that huge capital risk to both the community and to UAF of some sort of failure. So I believe, there's a number of ways this new plant both is helped by all the energy efforts that are going on, and I think we can help in a number of ways as well.
All right. Well, thank you for that, Bob. We really appreciate it. Thank you for coming in today.
You're
And I just
welcome.
wanted to say, as a UAF student myself, I'm looking forward to this new plan and how it can benefit UAF and myself and other students. But thank you for coming in today.
Excellent.
We appreciate it.
Thank you.
That's going to do it for us. I'm Samantha Larson. Thank you for joining us.